Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following by applying different trigonometric rules. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have in a quadrilateral ABCD, the line AB equals 25 meters, BC equals 20 meters, the line BD equals 30 meters, and angle ABD equals 10.5 degrees. Angle BCD equals 31.1 degrees. We are to find 1. The area of triangle ABD, 2. The size of angle BDC, and 3. The length of CD. Starting with the first part of the question, we are to find the area of triangle ABD. I'm going to start by highlighting the triangle ABD as shown. Now, because we weren't given the perpendicular height, the formula we're going to use is we have area of triangle ABD equals half of the two lines subtending the angle or the reference angle, which is AB times BD, sine of the angle being subtended, that's angle ABD. That is, ABD, this angle, is a reference angle. Therefore, area of triangle ABD equals half times 25 meters times 30 meters times sine of 10.5 degrees. Therefore, the area of triangle ABD equals, if you punch that in, we're going to have 68.34 meters squared to 2 decimal places. The next question says, find the size of angle BDC. To find the size of angle BDC, the triangle I'm going to use is triangle BDC. And using the sine rule, I have side BD, that's the first part of the question. Number 2, I have side BD. I'm going to find the ratio of the side and an angle facing it. The angle facing side BD is sine C, that's angle C, equals, we have side BC over the sine of the angle facing side BC, which is angle BDC. Slotting in our parameters, we have BD 30 over sine C, that's sine 31.1 degrees, equals the line BC 20 meters over sine of angle BDC. If I cross multiply, I will have 30 times sine BDC equals 20 times sine 31.1 degrees. So therefore, to find sine BDC, I'm going to divide both sides by 30. So I have 20 times sine 31.1 degrees divided by 30. That will give us 0.3444. Therefore, to find angle BDC, taking my sine to the other side, I'm going to have the arc sine of 0.3444. Arc sine is the second function of sine on your calculator. Therefore, angle BDC equals 20.15 degrees. For the third part of the question, we have to find the length of the line CD. To find the length of line CD, I'm going to use the triangle DBC like I did in the last part of the question. Using the sine rule states that the line CD over the sine of the angle facing CD, that's DBC, sine DBC, is equal to the ratio of BD, that's line BD, over the sine of the angle facing the line BD. In this case, that's sine C. However, we don't know what angle DBC is, so the first step is to look for angle BDC. Remember, DBC is a triangle, so therefore angle DBC, I have DBC plus angle C plus angle BDC equals 180 degrees. That's the sum of angles in a triangle, add up to 180. So therefore, I have DBC, that's the missing angle, plus C, 31.1 degrees, plus 20.15 equals to 180 degrees. Therefore, angle DBC using the balance method equals 180 minus 51.25 DBC equals 128.75 degrees. So now that we know our angle, I'm going to go back to the formula. I have CD, which is the angle I'm looking for, or the side I'm looking for, over sine of 128.75 degrees equal to the line BD, that's 30, divided by sine of the angle facing BD, that's 31.1 degrees. Like I did earlier, I'm going to cross multiply. So I have CD times sine 31.1 degrees equals 30 times sine 128.75. Therefore, CD equals 30 times sine 128.75 degrees divided by sine of 31.1 degrees. Therefore, the line CD, or the length CD, equals 45.3 meters to 1 decimal place. Let's look at the last example. In our last example, we have in triangle PQR, the line QR equals to 3 units, the line PR equals x unit, and PQ equals to x units, and the angle at Q equals theta. We have to show that cos theta equals x squared plus 3 over 4x. In this case, I'm going to use the cos rule, and because the angle at Q is a reference angle, I will start with the side facing the reference angle. So using the sine rule, I have x squared equals the sum of the square of the other two sides, so that's 2x all squared plus 3 squared minus 2 times 2x times 3 cos of the reference angle, that's theta. Simplifying, I have x squared equals 2x all squared will give us 4x squared plus 9 minus 2 times 2 times 3, that's 12x cos theta. I have x squared here. Simplifying, I'm going to make 12x cos theta my subject of formula, so I'm going to move that to my left hand side and move x squared to my right hand side. So what I will have is 12x cos theta will become positive if you get moved to the left hand side, and x squared will be negative when I move it to my right hand side, plus 9. I have 12x cos theta equals 3x squared plus 9, dividing both sides by 12x. I have 12x cancelled, 12x in 12x. I'm left with cos theta equals, I need to factorize or simplify by factorizing. The common factor for my numerator is 3. I'm left with x squared plus 3. And if I take out 3 as a common factor for my denominator, I have 4x left. 3 divided by 3, that's 1. So therefore, my cos theta equals x squared plus 3 over 4x, which is what I have in the question. Thanks for watching. Bye.